What you didn't see is my board just fell. All right, so now we're going to do the second part of 15.1. So I wrote down the equation. The chemist starts this reaction with a whole bunch of numbers, blah, 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 and then he reaches equilibrium, and they have a whole bunch of concentrations. At what point, at that point, the concentration is blah, 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 blah. What is the equilibrium constant for this reaction? All right, so there's a whole bunch of numbers, and here's the thing. Don't pay attention to all of them. They're just thrown in there to confuse you. Probably they did, because it's a lot of numbers and a lot of words. Find the ones that say at equilibrium. The only thing we're worried about here is equilibrium. So it's going to be the equilibrium of the products, NO2 to this exponent, our exponents are really big now, times this one, H2O, to this exponent over this one, NH3, to this exponent, holy cow, 4 times O2 to 7. Wow. So make sure you can use your calculator. Do this problem on your calculator. Okay, so now put your numbers in that it says at equilibrium. It reaches equilibrium in the concentration of NH3 is 0.80 and the concentration of O2 is 2.7 and NO2 is 0.40 and H2O is 0.60. Okay, so now you have M4, M to the 4th, M to the 6th, you have M to the 4th, M to the 7th, so these are going to cancel out, and this one should leave you with just an M on the bottom, so 1 over M, just so you know, you can kind of know what your units are going to be. And so you're going to put all of these numbers into your calculator. Please, please, please practice it to make sure you know how to do your exponents. And you should get K equals 2.8 times 10 to the negative 6th. Negative 6. That means it's super small, right? 0.000006, right? Super small. So what does that mean? That means that instead of making a whole lot of products, really, I can rewrite this like this. I really have a lot more reactants than products in this reaction. All right, so another thing that makes equilibrium problems easier is that if your anything in your chemical reaction is a solid or a liquid, I can ignore it. Just like before when I got an exponent of 0, I could kind of ignore it because that made it a 1. If I get anything that is a solid or a liquid, I can ignore it. So that makes these a little easier too. So let's do example 15.2. Hopefully my board doesn't fall this time. All right, we have NH4Cl. And that's a solid. Oh, that's telling me I'm going to love this problem already. And NH3, which is a gas, and HCl, which is a gas. All right, so it says, what is the equation to calculate the equilibrium constant? They didn't even get us any numbers. They just want us to set us up. Well, so K is always going to be the products over the reactants. This is a solid, so I can ignore it. So it's going to be the concentration of NH3 to this exponent, which is a 1, times the concentration of HCl to this exponent, which is a 1. Done. That's the end of that question. Super easy. So the next one, what is the equilibrium constant for this reaction? I'm not going to rewrite the whole reaction, but it's going to be the same thing. If you see a liquid or a solid, I can ignore it. You can't ignore aqueous solutions though. But water, H2O, is a liquid there, so it's going to be the products. It's not this equation. I'm not rewriting the equation. So it's the products, it's the concentration of CH3CO2, C2H5 over the concentration of CH3CO2H times C2H5 pH. And again, all the exponents are 1. You can either leave them off or put in a 1. It doesn't matter, just as long as you know how to use it on your calculator. All right. I think we'll do more next time. Good luck.